Hi, have you ever used Redis lists in production? So if you're using Redis heavily in production, you might be using it as stacks, you might be using it as queue, or for your worker queues, for your activity feeds, for your round robin scheduling, right? So even if I tell you one example of mine, we are using Redis a lot in production, and we use queues a lot for batch scheduling a lot of jobs, right? So let's say we have jobs for sending notifications, we have jobs for sending 10,000 emails to client, to leads, right? And internally we are using Redis lists, right? So in this video we will be deep diving into Redis lists. What are those, how they store values internally, and how you can use it to according to your problem space, or to according to what problem you want to solve, how you can use it. And in the end we'll also see internally how lists, they store your data, why they are so performant, right? So the overall big picture if I give you, so Redis list is just an ordered sequence of values, right? So from this diagram you can see it's just a sequence of blocks, and every block contains the value that you want to store in your list, right? And all the operations, whether it's insertion, whether it's deletion, it's open from both ends. So in Redis, lists act as a deque, which means you can either do insertion and deletion from the head, or you can do it from the tail. So that's really beautiful about Redis lists, right? There's only one trade-off in this, that if you want to access any element at any index, it would be on, right? So this is just one of the trade-off. And there's one more thing: you can't create a Redis list with 0 elements in Redis, right? Redis deletes the key automatically if you have an empty list, so it doesn't make any sense to create an empty list in Redis, right? And these are some of the examples where you can use Redis lists in production. You can use it for your worker queues, you can use it for stacks, round robin schedulers, right? And yeah, before deep diving into lists in more depth, like how lists store your data internally, what type of encodings Redis provides, we'll do some operations on lists. We'll do some hands-on on this. So what you can do is you can open the terminal, and here I'll start my Redis server. You can write Redis server, it will start your Redis server. Once you have Redis server started and running, you can open Redis CLI, and we'll do some operations on list here, just to give you an idea how you can maybe insert any element in the list, or delete any element in the list, or get any element in the list, right? So yeah, I'll also share these notes document with you in the YouTube video description. It's all present in my GitHub repository, which is public, so you can always check it out if you don't get any clarity in some of the concepts that I'm explaining right now. Okay, so let's say you want to push any element to a list, right? So let's say I want to push element, so you can use either lpush or rpush. Both is used for pushing elements, but the first element which is prefixed over here is the direction. So whether you want to push from the head or whether you want to push from the tail, right? So let's say I want to push from the head in my list, so you can give any name to your list. Let's say I want to give it name notifications. So I have a notifications list, and in this I have notification 1, notification 2, notification 3, right? And in the output it gives you the total length of your list. You can also push the notifications from the right, which is tail. So you can write rpush notifications n4, n5, n6, right? And let's say I want to pop or delete any notification. If you want to delete notification from the head, you can use LPOP, right? And you can write LPOP notifications, and how many notifications you want to pop out. Let's say I want to pop 2 notifications. So as you can see, it popped n3 and n2, right? There are some other commands as well, which is okay, it's similar. It's just appending X in the end. So it's basically used for that, hey, push the element only if the key exists, right? I can tell you one example. So let's say I do lpush X, and let's say I write any random list name. It could be my list 1, and I want to push 1, 2, 3 in it. So as you can see, it's giving me output 0. That means it didn't push anything. Why? Because my list 1 doesn't exist. But if the same we do it using lpush, it would work fine. Right? So that's the difference between lpush and lpushx. It's only used for pushing elements if this key already exists. But in our case, it didn't exist, so it didn't do anything. Let's do some other operations. So the operations which we did here was mostly for insertion, right, or deletion. Let's say you want to read something from your list. So there are some commands which Redis provides. Let's say you want to check the length of your lists. You can write length key. So let's run this. You can write length notifications, and yeah, if you run this, you'll see you have 4 items present in your list. Cool. And let's say you want to get your full list. Basically, you want to see what all elements are present in your list. You can use LRANGE. So what I'll do is I'll just write LRANGE, and then you can provide your list name, which is notifications, and then you have to provide starting and ending index. So let's say I want to get my list from 0th index to the last index, which is -1. So currently I have n1, n4, n5, n6 in my notifications list, right? You can also change the indexes. Let's say I want to get only first and from first to third index. So I have n4, n5, n6. Cool. So this command is basically used for viewing the elements in your list from particular positions, right? And you have lindex command as well. So let's say, just a second. So let's say I want to get element which is sorry, I said it wrong. So basically it gives you index, right? So let's say I want to, sorry, I told it wrong. So basically lindex, what it does is, let's say I want to get from my notifications list the element which is present at, let's say, 4th index. So right now I don't have anything present on my 4th index, so it didn't return anything. Let's say I want to get the notification which is present on my 2nd index. So as you can see, it gave me n5, right? So this command is basically just used for giving the element that is present at a particular index, right? There is one more command which is similar to it, which is kind of like opposite. So here you are basically getting the element that is present at the index, but let's say you want to know the index of a particular element. So how would you do it? You can write l position. Here you can provide the notifications name, and I want to, let's say, search where n4 is present in my notifications list, right? And as you can see, it's present on 1st index, right? So basically this is just the opposite of lindex. Lindex gives you index, lindex gives you element which is present at that particular index, and l position gives you index of the particular element that you are searching, right? So these are some of the reading commands that you can perform on Redis lists, and there are some other commands as well which you can perform to, let's say, update your list in place, right? So this particular command lset is used for overwriting any element that is present, you know, at a particular index, right? You can even insert a particular element before any value in the list. You can even remove any element if you want to, right? So let's do this example. I will remove elements from my notifications list. So you can write LRIM notifications, and how many items I want to remove. Let's say I want to remove 1, and which item I want to remove. Let's say I want to remove n4. So if you check your notifications list now, n4 wouldn't be present, right? So as you can see, it only has n1, n5, n6. So n4 was successfully removed. So in this way you can remove elements as well, right? What else? Okay, you can also try all these commands separately as well, because there are so many commands, and if we go one by one with all the commands, this video would be very long. But yeah, I will be sharing this notes with you on the YouTube video description, so that you can even try all these commands as well separately, right? Yeah, I think let's move towards blocking commands. So all these commands which we are performing right now on Redis lists, they are non-blocking. So let's discuss blocking commands as well. So these commands also look similar. You used LPOP, RPOP, right? But when you prefix B in this, it becomes blocking command, right? And it gives some powers to your queue. That's why it's known as queue superpower. I'll be explaining this as well, why it's known as queue superpower, right? So you can discuss, you can understand this. Okay, so let me open my terminal, and here I'll show you one example. So right now I have 3 notifications, right? So let's say I pop something from my notifications. So for getting something from the notifications, either I will use LPOP or RPOP, right? Okay. So in the similar way, you can use BLPOP as well. It basically does the same thing, but it takes one extra parameter as well, which is timeout. So let's say I give it timeout 5 seconds. Okay, so it did the same thing. It removed the element from the head. So right now N5 is present at the head, so it gave you N5, right? So if you check your final list, you have now only one element present, right? And what was this timeout value was? It's basically used for telling Redis that, hey, you can wait up to 5 seconds if you don't see any value to remove, because right now it had 2 values and it immediately removed N5, so it didn't have to wait for 5 seconds. So this timeout will only work in case the notifications list was empty, right? So that's where it's giving the queue superpower, I'll tell you. So let's say I'll again do BLPOP, right? So now your list is empty. Okay, so let's say now if I do BLPOP notifications, let's say I give it 5 seconds. Now you'll see it's not doing anything. Basically it went into sleep mode. It will wait for 5 seconds. It will try after 5 seconds to remove something. Okay, so this timeout was basically just telling Redis that, hey, wait for 5 seconds, and if you don't find anything within that 5 seconds, just return. So within these 5 seconds, it was basically in sleep mode because our list was empty, so it didn't do anything, right? So let's say I do the same operation, but here now I provide, let's say, 0 timeout. So in this case, what will happen is it doesn't know for how much time it needs to sleep, so it will sleep indefinitely, right? So this is the superpower of queue. So now what will happen is, let's say I open a new terminal, and here I'll open Redis CLI, and let's say another Redis client tries to push something on the notifications. Let's say I push something on my notifications, maybe N8. Now you will see, this BLPOP is executed successfully. Earlier it was in sleeping mode. It was like running continuously, indefinitely. But as soon as we pushed something from another client, it got executed successfully after 28 seconds. So this is how internally worker queues works as well, right? I'll show you with the example, right? Just a second. So let me open Xcalidraw, I think. Then it will be much more clearer to you. So let's say you have this worker, right? And this worker job is to pick jobs from the queue. So let's say you have a queue as well. I'll just change its color. You have a queue, right? And in this queue you have, just a second. Okay, so in this queue you have, let's say, notification 1, notification 2, right? So on up to, let's say you have 10 notifications in your queue. Okay, and this worker job is to get notification one by one from this particular queue. So it might, let's say in Python you might have code something like while true, if, sorry, basically you will be popping the notification from the queue. So let's say notification LPOP from the notifications list, and if you have a notification, you will basically process it, right? And after processing, let's say if you want to give some sleep, you can give that as well, right? So this is how normal worker would be working, right? They would be using non-blocking commands, right? The main problem in this is this loop is continuously running, right? The loop is continuously running, and what happens is every time when you run this loop, it's trying to pop the notification from the queue. If present, it processes it, else it moves forward, sleeps for 1 second, and again start from scratch, right? Basically it will again do the same operations after 1 second. So this loop is continuously running, it's not stopping at all. So what's happening is it's consuming CPU a lot, right? So you are consuming CPU a lot in this worker, right, along with memory, right? So that's where blocking command comes in, right? Let's try to improve this worker. So I'll just copy paste it, and now what I'll do is I'll use BLPOP, right? So BLPOP gives you 2 elements in the output. In the second output you gets the actual notification, and here you don't even need to do if notification or anything like that. You just say get the notification, process it. You don't even need to sleep. I mean, you can sleep, it's fine, right? So in this case what happens is here the worker goes into deep sleep, right? But this worker will only go to deep sleep if, let's say, this queue is empty, right? So let me just copy this as well. Let's say this queue is totally empty, right? So in this case what will happen is this worker will goes into deep sleep. Whenever worker goes to sleep, CPU is almost like negligible. You're not using CPU at all, right? So basically what happens is whenever another producer, let's say you have another Redis client or producer, let's say it pushes the data to this particular queue. Maybe let's say it pushed notification 10 to this particular queue. So as soon as this producer will push notification to this queue, worker will get active again, and it will immediately pop the notification from this queue, right? And it will reach here, and then the notification will be processed, right? So in this case the only advantage is that here we are not continuously running or doing the polling. Here we were continuously doing polling. Why? As you can see, we are first trying to pop the notification. If it's present, we are processing it. If it's not having any notification, we moved forward, and again we are doing the polling. We are again doing the notification popping, right? So it's consuming CPU a lot. But in this case we are not doing it. We are not doing the polling at all. We are just telling worker to go into a deep sleep, right? And that doesn't use CPU a lot, right? And as soon as someone pushes notifications into your queue, we get the notification, we process it, right? So that's how blocking command is very helpful, right? So this example is similar, which I just explained you, right? You can also take a look at this example when you get some time. At the end of this video I'll be sharing this in the YouTube video description, right? Yeah, these are some examples which you can try if you want to, right? Basically these are the examples telling you how you can use your lists in different scenarios. Let's say you want to use your lists as a stack, so you would mostly be using these 2 operations. If you want to use it as a round robin scheduler, you would be using lmove, right? So these are some examples which you can try, right? And these are some of the common mistakes. So LRANGE is a very slow command, especially let's say you have a very bigger list. So if someone tries to use LRANGE on a very huge list, your Redis server might get blocked because it's single threaded, right? And yeah, these are some of the common mistakes which people might do. You can read it. Now we will come to the main part that we wanted to discuss in this video, which is how internally lists are stored, right? So lists have 2 different encodings in Redis. First is I think it's, let's see, Yeah, so first one is listpack and second is quicklist. So listpack is generally used for smaller lists, right? So if you have a very small list, Redis will use listpack encoding. You can also check it here as well. So let's say I will push something in my notifications, and if you check the object encoding of this, right, you'll see it's a listpack. If you check the type of this, you'll see it's a list, but internally it gave it listpack, right? So basically it uses listpack for smaller list, and internally how it would be represented is it would be represented as a contiguous block in memory, right? And every block will have some information. So in case of listpack, you have total bytes information, number of elements, and the actual elements that you're storing in a list will be present here, and in the end you will have some terminator bytes, right? And how these entries will look like, every entry will look like this. Every entry will have encoding and length along with the data that is present and some back length, right? I can also explain this to you in the Excalibur if you want. So let's say you have 1, 2, 3 in your list, right? So internally how it would look like is, let me show you. So so your first element will be stored as like this, encoding plus length. So yeah, this is just okay, let's say it's just a simple character. Okay, let's not take numbers. Let's say it's A, B, C, right? So the first character encoding is string. How much length it is? It's 1, right? And then it will store the actual data that you're storing, and then it will store the back length. So in this case it would be 2, right? So it will basically store every character like this, right? Here you'll have B, here you'll have C. Okay, so the first part is encoding plus length, second is the actual data, and the third is back length. So back length Redis uses to, let's say if you want to delete this particular item, it knows that it has to delete 2 blocks in the memory. So that's what it used for, I think. Yeah. So this is just I explained, and this is just a high level overview, right? The one thing which I explained is how each entry is stored, but if you store all of this together, you will have one more block, right? And bring to front. Okay, and here in the beginning you have some other metadata as well, like how many total bytes were given to these in the memory, how many elements you have, right? So let's say total bytes are, I don't know, maybe 40, and total elements you have 3. Okay, you can just store it here, and in the end you have null terminator, right? Cool. So this is how it will look in your memory, this particular list. And for a smaller list we generally use listpack, right? Cool. And yeah, what about quicklist? So quicklist is similar to listpack, but it's mostly used for bigger lists. And one thing I forgot to explain you, that just a second. So in Redis, if we talk about the older way how lists were usually stored, they were stored as a doubly linked list, right? But in case of doubly linked list, you see you have so many pointers. You have previous pointer, you have next pointer, you have data pointer, which costs you a lot of memory, right? Okay, so 3 pointers, they are costing a lot of memory. So that's how listpack came into picture. It doesn't use pointers at all. It uses this contiguous block of memory representation, which is really cool, right? But in case of quicklist, obviously it will be using now linked list. And here you can see every element will be a listpack node. So let's say you have this bigger list, and every node here will be a listpack itself, right? So that's how it maintains a bigger list. I mean, if you want to see it in more details, you can check this notes. But yeah, I'm just giving you a high level overview. Using this diagram as well, you can understand it very well. So let's say you push any element in your list. If that list is already a list pack, and if it's not exceeding the size, you have some threshold in the Redis that if it's more than this threshold, you can convert this particular list pack to quick list, right? If let's say it was already a quick list, now it will check whether that we can move that particular element to head or tail or not. If we cannot move it, it will basically create a new quick list node. So yeah, I think this was all about how lists internally work and how they store data. And I have also included some interview questions as well. So what is the difference between lpush and rpush? You might be able to answer it, after watching this video. And how do you implement FIFO queue and LIFO stack with one list? Yeah, you might be able to answer it. So why LPOP is O1 and LINDEX is ON? You might be able to answer it, right? What is the difference between listpack and quicklist? So yeah, these are some of the interview questions. For each of them, answer is given. So yeah, I think this video was really interesting. I might have told some things in it, maybe not accurately, but yeah, I will be sharing these notes in the YouTube video description. You can always check it out. And yeah, you can ping me if you have any doubts or anything. And yeah, I think in the next video we will be discussing hashes, sets, sorted sets together, I think, because otherwise this video series is going to be very long. So yeah, stay tuned guys. Thanks.